Let's start section 2.5. 2.5 transformations of functions. It's a longer lecture, it's a long lecture, but again, it's a review with different name from intermediate algebra. It means if a function is given to us, a graph of a function, how we can move or shift our graph from one place to another place. Or in another language, if a parent graph is given, they can ask you to graph different graphs of that function based on the parent. Let's start first with the graph of common functions. Graph of common functions. Some people call this the gallery of functions. Some people call this topic parent functions. Which way you call it, I'll explain it to you. Name is different, but actually we are talking on the same topic. Graph of common functions. Here I will introduce to you at least 6 important common functions, the graph of them, which you will see it a lot in your book or in many books, correct? Number 1, you have to memorize these shapes. At least you have to know by heart what does it mean. X, Y. Let me draw here a line. One of the common functions or the parent functions is, if I draw this one in a much better place, let me draw it here. This line. And we know what is this function. This function is f of x equal x, right? F of x equal x, or another meaning y equal x, right? This line is y equal x, a line, a straight line, or in general, y equal mx plus b. The graph of a line is this, but the simple form of it is f of x equal x or y equal x, which is a line, diagonal line that passes from origin, correct? We call this one of the common functions. What is the domain of this function? Few things. The domain of this function is from negative infinity to positive infinity. You can see it, right? The values of x starts from negative infinity to positive infinity. The range for this function is from negative infinity to positive infinity. These are what I'm writing here. They are the characteristics of your common function. These are the characteristics of f of x equal x, correct? The function is increasing, right? The function is increasing in which interval? From negative infinity to where? To infinity. You see, this function actually is increasing in all intervals from negative infinity to positive infinity. Which kind of function is this? It's an odd function. Correct? I will not explain here again how I know it's odd. If you replace x with negative x, you know f of negative x equals negative f of x Because of that, it's an odd function. We already had that lecture, correct? Number 2. Let me draw a V shape for you. It's another common function, which we call it absolute value function, correct? It means f of x equals absolute value of x. This is another common function or parent function, correct? What is the domain and range of this function? As you see, domain of this function is from negative infinity to positive infinity. And the range is from where? From 0 to positive, from 0 to positive infinity. Correct? This function is decreasing in which interval? Look, your function is decreasing from negative infinity to where? To 0. Correct? From negative infinity to 0. It's the interval of decrease. And also your function is increasing from which interval? Here, right? From 0 to infinity. And definitely, you see, because it's symmetric about y, this is an even function. I don't know if you can remember all of these information, but at least the shape, absolute value shape, V shape. F of x equal x, a line, correct? Remember the shapes, correct? Number 3. If I draw here for you a parabola, this function is f of x equal x squared, another parent function or another common function. Correct? Now, some information. Domain. The domain is from negative infinity to positive infinity. Range. The range, as you see, starts from 0 to positive infinity, up to positive infinity. Decreasing from negative infinity to 0, increasing from 0 to infinity, and of course, this one is also an even function. Correct? Number 4. xy, this function. This function is f of x equals a square root of x. It's one of the main functions or parent functions. some information starting with domain. The domain of this function is always starts from 0 to infinity. Range, what I'm writing, range starts again from 0 to where? To infinity. This function is always increasing from where? From 0 to infinity. That's the interval of increase for this function. Which kind of function is? You see, this function is neither. Correct? This function, you can write it neither. It's not even, it's not odd. This function, in category of even and odd function, this comes as a neither. It's not an even function, and it's not an odd function. Number 5. You saw before all these graphs, right? Now here we make kind of table for them because now we are using them, right? This function. This function is f of x equals x cubed. Correct? Some characteristics of x cubed. Domain. The domain is from negative infinity to positive infinity. Range, negative infinity to positive infinity. This function is again increasing in all intervals from negative infinity to infinity. Correct? And this one is an odd function. You see, because it's symmetric about where? It's symmetric about origin. That's why it's an odd function. Correct? Number 6. In your book, they give you as a 7. They give you 2 lines, but only 1 line. Correct? We know it as a parent. X, again, Y. This graph is like this, like something like S. Oops. Here. F of X equals cube root of X. It's another parent graph. Characteristics, domain from negative infinity to infinity. Range, negative infinity to infinity. Increasing, always this function is increasing. Which interval? Of course, negative infinity to infinity. And this is again an odd function. We call these 6 functions that I listed here for you. If I zoom out a little bit, but it goes really small if I zoom out. We call all these 6 functions the parent functions or the common functions. A good table is on page 283 of your book, correct? If you go to page 283 of your book, all the functions are there. The table is there, correct? Now, after you memorize these shapes, let's talk about transformation, correct? And let's start, I will write here A first, with vertical shift. What is vertical shift? If I draw here a function for you, any function, any type of function, correct? This is X, this is Y. I will draw a function, for example, like this. Let's name this function, for example, f of x. Vertical shift means you shift your function on a y-axis, move it up or move it down unit. How many units? For example, if I draw the same shape in this point, I will name this function f of x plus c. C is a constant, correct? It's a number. You shifted your graph vertically C unit upward, correct? Or same function or same shape if I use here, even I could use the same graph, but it will be a lot drawing there. Let me draw another one. This is, for example, your f of x, the graph of a function. And if I move this function C unit down, then this I can write f of the green one will be f of x minus c. Actually, I shift my graph C unit downward. Correct? We call this, both of them, vertical shift. Now, if a function, f of x, for example, equal x squared is given, f of x equal x squared plus 2, it means you are shifting the graph of x squared 2 unit upward. F of x equal x squared minus 3, it means you are shifting your parent graph 3 units downward. Correct? I will do 2 examples here for you, and I'll explain how you do the vertical shift. Correct? Because in your test, when you learn transformation or even some people call it translation, some people call it shifting. When you learn shifting, translation, or transformation, you have to draw always your parent graph, and based on that, you can graph the function that's given. You cannot draw immediately this one. I know, why not this? Immediately I'll make a table and I'll draw this. No, but because you're doing here transformation, you have to show the parent graph, right? Let's do examples. I'll explain there for you. Example number 1. For example, they are asking you to graph f of x equals absolute value of x plus, let's say 2. how I should graph absolute value of x plus 2. This is the important part of this problem. I should find what is my parent graph. I'm sorry, the parent graph for this given problem. The parent graph for this, or the common graph for this, is f of x equal absolute value of x. Because here you see you have plus c. This part is not important. That is the parent. Start with drawing a table. Here is x. Here you can name f of x or y. It doesn't matter what do you name. At least for this graph, you need 5 points. 0, 1, 2, -1, -2. Look at this. F of x, I will show some calculation, not all of them, because don't complain that he's not showing everything in the lecture. F of x equals absolute value of x. What will be f of 2? I'll show just one point. F of 2 equals absolute value of 2, which gives you 2. When x is 1, f of x will become 1. If f of 0, this one 0. F of -1. Absolute value of -1 is again 1. F of -2 gives you what? 2. If I'm going to graph this, oh my ruler. If I'm going to graph this for you, let's graph it here. I want to do a good graph. That's why I'm using the ruler, correct? X, Y. When X is 2, Y is 2. X1, 2, 1, 2. X2, Y2, this point. X1, Y1, or let's make this graph a little bit bigger. Let's do it, make it bigger because hey, everything is gone. Okay, only I will erase this part. Let's put our units bigger. X1, X2, Y1, Y2. 2 and 2 will be here. 1 and 1 will be here. X0, Y0 here. X -1, Y1 will be here. X -2, Y2 will be here. And if I connect these points, it gives me a V shape, which the vertex is at 0, 0. That's my parent graph, correct? Now, the given problem is f of x equals absolute value of x plus 2. It means shift all of your points 2 units up. Some students, they want to do on the graph, they want to move 0 here, they want to move 1 here. It's a bit difficult to go that way. If you have enough practice, you can do it. What is the easy way? Look at my table. 2 is your C, right? This is your constant. When you do a vertical shift, if your C is positive, always add C in the Y column or f of x column, or subtract C from, if you do downward, from Y column, correct? I will add 2 here. I will add 2 here. I will add 2 here in all points. And let's see how much it becomes. 4, 3, 2, 3, 4. Now, I will use my x and the new y, or the new f of x. When x is 2, y is 4. X is 2, y 4. 1, 2, 3, 4. 2 and 4 will be somewhere here. When x is 1, y is 3. x1, y3, this point. When x is 0, y is 2. x0, y2 will be here, this point. When x is -1, y is 3. -1, y3, somewhere here. And -2 and 4 will be somewhere here. Now, if you connect these points, this will be the graph of the function that they are asking you to graph. This is the graph of f of x equals absolute value of x plus 2. I shifted the graph 2 units. You see, 1 unit, 2 unit. The graph shifted 2 unit. Look at the blue. 1 unit, 2 unit. The graph shifted 2 units upward. If it was -2, all the points shifting 2 units from the parent graph, 2 units down. Correct? Now, let's talk about horizontal shift. Horizontal shifts. Again, if a function, let me draw, if a function is given, a function f is given to you, for example, I'll draw here another shape, something maybe like this. Let's say this function is function f, right? This is f of x. If I shift my function C unit to the right or C unit to the left, we call this a horizontal shift. For example, if I move this function C unit to the right, correct? Remember, this one will be f of x equals f of x equals f of x minus c. Focus here, x minus c. The sign is negative, but the function is moving, shifting towards right. If I shift this function, c unit, to the left, this function will be f of x equals f of x plus c. Those of you that you had intermediate algebra class, there your professor explained this like this. For example, the quadratic f of x equals x plus 2 squared. They called there this number h, right? And you had the vertical shift as a k outside. You did it this way in intermediate algebra. Vertical shift, horizontal shift. H was your horizontal shift. K was your vertical shift. But here we just use C. We name it C. Remember, your professor on that time told you that if H is positive, it means your function is shifting to the left. If H is negative, your function will shift to the right. That's how we explain it here with C, correct? It's always opposite sign. If the sign is positive, you go left. If the sign is negative, you go right, correct? This is all about horizontal shift. Let's do an example. Example 2. F of x equals x squared. First, x squared, let me give you not the parent graph, let me give you the function. X minus 2 squared. They're asking you to graph this. F of x equals x minus 2 squared. Correct? What is the parent graph for this? The parent graph for this is f of x equal x squared. First, I will graph this. First, I will graph this. X, or here you can name f of x or y, whatever you name it. Again, you need at least 5 points to graph this. 0, 1, 2, -1, -2. All, I just know these 5 numbers. Okay, they are the best numbers to use. I don't want to show it for you how. Plug in 2 there gives you 4, plug in 1, 1, 0, 1, and 4, right? You end up with this. And if you graph, x, y, x1, y1 here, 0, 0, 2 and 4, 2, 3, 4, 2 and 4, -1 and 1, and -2 and somewhere here 4. Correct? The graph will be a parabola like this. Now, how to do the shift? Because I have to graph this one. That's my parent. I have to show this graph. Take the opposite sign. What is the opposite of -2? The opposite of -2 is +2, right? Then add 2 to the x column. And it gives you the new points. 2 plus 2 gives you 4. 2 plus 1 gives you 3. 0 plus 2 gives you 2. -1 and 2 gives you 1. -2 and 2 gives you 0. Correct? These are the new points for your x. Now, use the new points. 4, 4. When x is 4, y is 4. Somewhere here, 4, 4. When x is 3, y is 1. 3 and 1. When x is 2, y is 0. x2, y0, this point. x1, y1. 1 is here. x0, y4. x0, y4 is this point. And if you connect these points, you see your graph shifted 2 units to the right. This is the technique for the shift, horizontal shift. If it was plus 2, I will subtract 2 from x column. Always remember opposite sign. Take opposite sign. Correct? Take the opposite of that number and use the x column. Now, some problems, they give you both shifts. Correct? They give you both shifts. Let's say example 3. They're asking you to graph f of x equals, let's say what? Another shape. Square root of x. Let me give you a simple one that you see before. The square root of, for example, f of x equals, let's say, x plus 1 cubed minus 2. Correct? Immediately as I see here, cube, I will know my function, my parent function is f of x equals x cubed. First, I will graph this. I will use a table, x, y, 5 points minimum. You can do more, but not less than 5. 0, 1, 2, -1, -2. A quick question. It's not a face-to-face class that I could ask you a question. Here you see I'll choose negative and positive numbers, but if I have f of x equals, for example, square root of x, can I do the 5 points here also the same thing? 0, 1, 2, -1, -2. Is it correct? That's why I give you the parent graphs table, and I talk about domain there. The domain of this one starts from 0 to infinity. It means you cannot use negative numbers. The domain of x cubed was from negative infinity to infinity. That's why I use negative also here, correct? Be careful, because I cannot do here like 20 examples for you, correct? It's a lecture. When you do your homework, you deal with different functions. Just focus on the domain, correct? Now, plug in these numbers to the parent graph. 2 cubed gives you 8. 1 cubed gives you 1. 0 cubed, 0. -1 cubed gives you -1. And -2 cubed gives you -8. Correct? Let's graph this first. X, Y. X2, Y8. I will start here small, x2, y8. 1, 2, 3, 4, 5, 6, 7, 8. x2, y8 will be here. x1, y1. 1 and 1 will be here. 0 and 0 will be here. Negative 1 and negative 1 here. And negative 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 and 8 will be here. And if I connect these points, it gives me the shape of f of x equal x cubed. Correct? Now, I want to do both shifts in it, correct? Because the actual problem, look at here, you have both shift, horizontal shift, vertical shift. Vertical shift is always the same sign. Same sign, remember. Horizontal shift, opposite sign. For the vertical shift, I'll take this number and I'll subtract from y. Minus 2, minus 2, minus 2, minus 2, minus 2. Here it gives you negative 10. Here it gives you negative 3. Here it gives you negative 2. Here it gives you negative 1. Here it gives you 6. Correct? Vertical, horizontal shift, opposite of 1. Opposite of 1 is negative 1. I'll subtract negative or I'll add negative 1, right? It's same thing. Subtract 1 or add negative 1. Two minus 1 gives you 1. 1 minus 1 gives you 0. 0 minus 1 gives you negative 1. Negative 1 gives you negative 2. Negative 2, negative 1 gives you negative 3. Now, to graph both shifts, use the green and use the red. The resulting green and the resulting red. I'll graph it with blue. When x is 1, y is 6. x1, y6. 1, 2, 3, 4, 5, 6. This point. When x is 0, y is negative 1. x0, y negative 1 here, this point. When x is negative 1, y is negative 2. Negative 1 and negative 2 will be this point. X is negative 3, y negative 10. Negative 3, x negative 3, y 10. If this point is 8, this point will be 10, right? And if I graph the blue, function, that will be the shift, both shift. 1 unit down because I had here positive 1, 2 units down. Actually, I went 2 units down. And because I have positive 1, my graph, you see, shifted 1 unit to the right here. This is how you do both shifts. Correct? Next topic that we want to discuss is reflection. Reflection about y-axis or reflection about x-axis. About x-axis. When you get a reflection about x-axis, if you have a function in the form of y equal f of x, correct? The reflection about x-axis is y equal negative f of what? X. It gives you always a reflection about x-axis. Example, if you have y equal x squared, the reflection of, if someone asks you to find the reflection about x-axis, do this, y equal negative x squared. The negative of your function, you see, the negative of your function is the reflection about x-axis. Here, that's the good example. Let's do this example. Y equal x squared. I know the table for y equal x squared, right? At least this table is easy to memorize. 5.xy 0, 1, 2, negative 1, negative 2. Here you have 4, 1, 0, 1, 4, right? Let's graph it. Zero, zero, 1, 1, 2, 4, somewhere like this. 0, 0, negative 1, 1, and negative 2, 4. This is the graph of y equal x squared. How to find the reflection? Look here. Your y, change all the values to negative, 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 negative. If you change the values of y to negative, it gives you the reflection. That easy, because I have to look for the negative f of x. It means in your table, multiply it by negative 1, everything, the y column. Multiply the y column by negative 1. It gives you the reflection. 0, 0, 1, negative 1, 2, and negative 4, 0, 0, negative 1, and 1, negative 2, and 4. This will be the reflection of that graph. I'm not focusing here too much to give you really beautiful graphs. I'm trying to explain, correct? Reflection about x. Reflection about x axis multiply y with negative 1. That's the technique. It gives you reflection about x-axis. Right? Reflection about next one is reflection about y-axis. Y-axis. If you have a function y equal f of x, the reflection about y-axis will be y equal f of negative x. That gives you a reflection about y-axis, correct? For example, if I have f of x equal square root of x, and someone is asking me to find the reflection of this function about y-axis, I will look for this. F of x equal square root of negative x. You may see here, you may tell me it's impossible, a square root of negative x. Yes, that's right. But when you graph, only multiply the x column by -1. Multiply, because you cannot take the square root of negative numbers, right? Multiply the x with -1. It gives you reflection about y-axis. Correct? Let's do an example. Find reflection about y-axis. The function is given f of x equal square root of x. I want to find the reflection of this function about y-axis. The domain of this function is important for me. The domain starts from 0 to infinity. Then when I make my table, to focus only on positive numbers, at least 5 points, because you're again drawing a curve. 0, 1. I will not choose 2 because I know the square root of 2 is not exact. 2 doesn't have a perfect square root. I'll jump to 4. 4 has a perfect square root. 9 has a perfect square root. Choose these such a kind of numbers for the square root. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. The square root of 9 is 3. And graph your function. Zero, zero, 1, 1, x4, 2, 3, 4, y will be 2. I will not draw the 9 because it's too far. I don't have that much space. At least I know the shape. This is the shape of f of x equals square root of x. Now, reflection, I do this. Of course, for 0, you don't need a negative. I will multiply the rest with -1, which gives me -1, -4, and -9. Then 0, 0, -1, and 1, -4, and 4. -4 and 2. That will be the reflection of this function, f of x equals square root of -x. That's the reflection. Correct? Next topic, vertically vertically stretching. Vertically, yeah, let's use this word. Stretching and shrinking. A graph can be vertically stretched, and also a graph can be stretched, correct? When we talk about stretching a graph vertically, it means your graph is kind of closing, correct? When we talk about shrinking, the graph kind of opens, correct? How? Let me explain it to you. For example, if I have a function f of x, correct? Let's draw a function like this. For example, this is a function f of x. This is function f of x. Vertically stretching, if I talk here about stretching, vertically stretching means the graph will go this way. You will see something like this. The red one is vertically stretched. And this one, if we name the black one, oh my God. I miss whiteboard and markers. When I do this, the black one will be y equal f of x. The red one is your vertical stretch. It means y equals cf of x. A positive number times function gives you always a vertical stretch. Again, in intermediate algebra, you had it this way. For example, for quadratic, you had x minus h squared plus k, and your professor explained to you if you have an a here outside, if a is positive, your graph opens narrow. On that time, we would use this word, opens narrow. It means the graph is stretching vertically, and if a is negative, the graph opens wider, they told you on that time, which I'll show you here. That one will be stretching, correct? Or shrinking. If I draw here another function for you, same thing. If this is this is y equal f of x, if I multiply my function, if I multiply my function with a negative number, I will see this blue one. This one will be fy equal too close, I'm writing too close. This one will be y equals negative CF of x, correct? This will be shrinking. Examples are really easy. Let's do at least one example. F of x equals x squared. We already know the parent graph for x squared, and we know the table for that. We did at least few examples today for this. The table for f of x equal x squared is like this. 0, 1, 2, -1, and -2. Here 4, 1, 0, 1, and 4, correct? x1, y1, 0, 0, -1 and 1, 2 and 4, 2, 3, 4, 2 and 4, correct? And -2 and 4. If someone is asking me to graph f of x equal 2x squared, correct? 2x squared. Here I have a vertical stretch. What you do, the easy technique is multiply your y column by the number, whatever that c is. You see, f of x or y equals f of cf of x. C is 2. It gives you 8, 2, 0, 2, 8. Now, when x is 0, y is 0. When x is 1, y is 2. x1, y2. When x is 2, y is 8, somewhere here, somewhere maybe here, correct? -1 and 2, -2 and 8. You see the graph opens narrower or actually stretches vertically. Same way you can do the shrink. If this number, if you multiply, if they ask you to graph f of x equals -2x squared, just multiply the y column with -2. You will see the graph will open. Not negative. Not negative, I'm sorry. Not negative. I have to correct here the lecture. Not negative. C, if C is greater than 0, less than 1, with a fraction, not negative. I'm sorry, not negative. This lecture is too long. For example, if they ask you to find 1/2 of x squared, in that case, the graph will be open. Correct? Correction here, it's not negative in the lecture. C between 1 and 0. Here your C is greater than 1. Correct? If you go to page 291 of your book, there is a beautiful table at the end of the page that what I explained in this lecture, actually all of them is written there in that table for you, right? You're talking in that table about uh, vertical shift, horizontal shift, reflection about X, reflection about Y, vertical stretching, horizontal stretching. You're talking about all of them in that table, right? This lecture was a long lecture. Please practice because I just did one or two examples. If now you tell me if I do like for each uh, part of this lecture, 5 examples, this lecture will be 10 hours long, right? I cannot do that. I just did one example. There are different examples in your book. Practice with, and if you have question, please use office hour and come and ask me, right? I'll stop the lecture here and see you all in 2.6.